Week 3 extension. So the first question says, which equation represents the function? Alright, so this is the function that's being represented below. Okay, so what you need to know firstly, guys, is that whenever you see a U or an upside down U or an N shape, okay, that's depicting something called a parabola. Alright, a parabola is anything where the highest coefficient is an x squared. Okay, so essentially, what do we need to know this for? Well, whenever you have a U shape, that means that the number in front, the leading coefficient, okay, so again, the leading coefficient would be positive. All right, whenever you have an N shape, that actually means that the leading coefficient, okay, is negative. Okay, so again, a U shape means that the leading coefficient is positive. An N shape means the leading coefficient is negative. So that just means the number in front in this case would be negative. Okay, here the number in front is negative, so I can leave that one. Here, technically in front of it is a positive 1. When you don't see a number in front, you assume it's a positive 1. But we need a negative 1 for it to possibly work. So this one is wrong. Here it has a positive 6. That's not a negative number. So this one is wrong. Okay. Here we have a negative number, technically a negative 1. Okay. So we're going to leave that one for now. Here, technically in front of it would be a positive 1. And we needed a negative number. So this one is out. Okay. So now let's try to identify which one of these two answers would be the correct answer. To evaluate that, you need to find something called the vertex. Well, the vertex is where all points meet, okay? So in this case, the vertex all meet right up here at the top. This is called a maximum vertex, okay? So to find our answer, we need to try to find the coordinate of that vertex. Well, the coordinate would be -3 for the x and +4 for the y, okay? But what should you remember when you're talking about your vertex? Well, to convert the vertex to vertex form, because that's what these are all in, vertex form, okay, we need to try to do the opposite of the x value and the same as the y value to get what goes in the vertex form, okay? So the opposite of a -3 is a +3. The same as a +4 is a +4, and that's what you use to represent your vertex form, okay? So the number inside of the parentheses of your vertex form would be a +3, and the number on the outside would be a +4. This would be my answer. Okay? This one's wrong because, again, they did not change it from vertex to vertex form. Okay? So let's try the next one. So the next one says, the table below represents an absolute value function. Well, how does an absolute value function look? Well, an absolute value function is either a V shape or an upside down V shape, okay? So it says, what would be the vertex, okay? So we're trying to find the vertex using the table. So what you need to remember is that the vertex, when you're given a table, is in between where y values repeat. So again, the vertex, okay, would be in between, okay, where y values, okay, repeat, okay? However, in this case, do we see y values? No, we see x and f of x. Well, what you should know for algebra is that another name for your y values is also f of x, all right? So another name for f of x is y, all right? So we need to look in between where the y values repeat. So here I see a 4. Here I see another 4. So that means my vertex is somewhere in between these 2 points right here. So again, I have the points -2, 4 and -1, 4. Our vertex is somewhere in between here, okay? So what I'm going to do is that I'm going to graph this so that you can better see what I'm saying. So technically I have a graph that looks like this. -2, 4 would approximately be here. -1, 4 would approximately be here. 0, 6, 0 for the x, 6 for the y would somewhere be here. 1, 8 would somewhere be up here, so 1, 8 approximately. And then 2, 10 would be somewhere here, okay? So if we look at that, we don't really see a vertex, but again, we need to be in between where here repeats, okay? So looking at our points, negative 3 is 6, negative 3 for the x, 6 for the y would be somewhere up here. That's not in between these 2 points, so this is wrong. Negative 1.52 would be, so negative 1.5 would be somewhere right here, and 2 would be somewhere here, okay? So negative 1, 2 would be approximately here, okay? So now, that could actually be one of our vertexes, so that actually could work, okay? Negative 1, 4, so this one could work, okay? Negative 1, 4, negative 1 for the x, all right? 4 for the y would be right here on this exact point. That's not in between these points, okay? Negative 2, 4, negative 2 for the x, 4 for the y, all right, would be somewhere up here, okay? Or rather, this exact point, so that wouldn't work, okay? Negative 1, 3 would actually be right here, negative 1, 3, okay? So this actually is also in between those points, okay? The one that I'm leading towards is more the negative 1, 3, or rather the negative 1, 2, okay? However, both of these solutions would work in this case because both of them are in between where those values repeat, okay? So again, just like that. So let's try the next one. So the next one says, what is the range of y equal negative 1/2 absolute value x minus 4 absolute value plus 6, okay? So what we're going to do for this, guys, is that we're trying to find the range. The range is your y values, okay? But in finding your range, we must try to graph this, okay? And to graph it, I need to find the vertex, okay? So the vertex can be found by doing the opposite of this number and the same as this outside number, okay? So opposite of a negative 4 is a positive 4. Same as a positive 6 is a positive 6, okay? So I'm going to go ahead and sketch a graph, okay? And I have positive 4 for the x, okay? And positive 6 for the y. So that's somewhere approximately here, okay? So now we're going to go ahead and plug in numbers to the left of it, okay? So again, if this is 4, 6, to the left of 4 would be 3, to the left of 3 would be 2. So let's try to plug in 3 and 2 into our equation to see what we get, okay? So I would have negative 1/2 absolute value 3 minus 4 absolute value plus 6. So I would have negative 1/2. 3 minus 4 is negative 1 plus 6. The absolute value turns this number into a positive number. So I have negative 1/2 multiplied by 1 plus 6. Negative 1/2 times 1 is negative 1/2. Plus 6 would be 6 plus negative 1/2 is 5.5 or 5.5. Okay, so that coordinate would be 3 and 5.5. So that would be approximately right here. Okay, now I'm going to plug in 2. So I would have negative 1/2. Okay, absolute value 2 minus 4 absolute value. Okay, plus 6. So then I would have negative 1/2 absolute value. 2 minus 4 is negative 2 plus 6. So the absolute value turns the number inside of it into a positive number. Then plus 6. Negative 1/2 multiplied by 2 would be negative 1. And negative 1 plus 6 is positive 7. So that means when I plugged in 2, that would be negative 1 plus 6 would be positive 5. I'm sorry. Okay, so that's positive 5 instead. All right, so when I plugged in 2, I would approximately get 5. Okay, and you know for an absolute value function, the points here mirror on the right side. So that means if I plugged in 5 and 6, they should also mirror these same points. So it will be 5, 5.5, and then 6 and 5. Okay. So we could try to go ahead and sketch our graph. So our graph will look something like this, okay? And we need to use this to find the range. The range is your y values from the highest to the lowest or lowest to the highest. Because right here is the highest point it goes, this would be the highest or the largest thing that your y value can be. Because this is where it's coming from, all the y values will be less than 6, okay? So in this case, we would say that all the y values, okay, will be less than 6, okay? So in this case, the answer would be this one right here, okay? So again, just like that. All right, so this one's pretty difficult, so make sure you ask a lot of questions on it, okay? So the next question. So the next question says, a parabola is defined by the equation y equal a parentheses x plus b squared plus c. If the parabola, and again a parabola is either a U or an N shape, is opening downwards, so if it's opening downwards, okay, all right, what must be true about A, B, and C, okay? Well, in this case, if it's facing downwards, what did I say for the previous question? It means the leading coefficient is negative. In this case, the leading coefficient would be A. So again, if it's an N shape or if it's facing downwards, that means the leading coefficient or A would be negative. All right, so A would be negative. Okay. So in this case, all right, I'm seeing this as that resultant, all right, and that's the only thing that you can guarantee to be a result, all right, that your A value would indeed be negative, okay? You could also suggest, so if the A value, if this was negative, if B was also negative, how would we represent that? So if we had a vertex of negative dots, and then I would be positive a number, and then positive this, so positive that, and that would be the vertex, and then so like 3 2. So this is the only one that we could guarantee to be negative. All right, I don't think B and C would have to be negative, but I'm pretty sure A has to be negative. All right, but ask questions on this if you find it still difficult. All right, so the next one. So it says the graph of y equal f of x is shown below. What would be the vertex of y equal f of x minus 4 plus 2? Well, this one's pretty easy, guys, because all you're doing is just trying to transform it using this function, okay? But you can find what that vertex will be just by doing the opposite of this number and the same of this number, okay? So opposite of a negative 4 is a positive 4. Same as a positive 2 is a positive 2. So this would be 4, 2. Okay? What you would normally do on delta math, guys, would be that you would try to do a positive 4 for the x-axis. So shift it 1, 2, 3, 4. And then a positive 2 for the y-axis. So that means you're going to go up 1, 2. So this is what your parabola would look like now. Okay? So that's what you would also need to do on delta math. Okay? So again, just like that. So then the final question. So then the final question says the function f of x is the absolute value is transformed with g of x. F of x is shown in the graph. G of x is represented on the table. So what is the equation of g of x? So my aim first is that I need to graph this function, okay? Because f of x is already graphed for me. So I need to graph this. So negative 2, negative 4. Negative 2 for the x, negative 4 for the y would be right here. Negative 1, negative 5, negative 1 for the x, negative 5 for y. 0, negative 6, 0, negative 6 would be approximately here. 1, negative 5, 1 for the x, negative 5 for the y. And 2, negative 4, 2 for the x, negative 4 for the y. Okay? So this is what my graph will look like. So I always start from the left. Go to the right, try to extend it all the way. So I need to try to figure out how did this become this? Well, they seem to look almost exactly similar. The only difference is that this is now a little bit lower. But by how much is it lower? It's lower by 1, 2, 3, 4, 5, 6 points. Okay? If it's lowered by 6 points, all you're essentially doing is that you're transforming it by changing the y values or the number that would be on the outside of your absolute value. Because it did not go left or right, the number on the inside would stay the same, the number on the outside would change. So in this case, I would have the absolute value. Because the inside didn't go left or right, that stays the same. The number on the outside, we went down 6 times, so that's a negative 6. Alright? So the answer would be this right here. So again, just like that.